Fellas, look at him. This is allegedly the biggest and the meanest and the nastiest, the hottest pipe hittingest impact driver available on the market. It's the 40 volt Makita, the XGT. Today we're going to compare it against the LXT. The whole test, the whole shebang is really going to revolve around this tool. You can see the review of this tool later. So basically, I think that the format for the test, I'm really trying to just kind of speed through all this nonsense. So we're going to start with the drag races. As you can see, the ass whooping goes to the Makita, but it's not a big ass whooping. I mean, you would expect for a tool with twice the volts to do twice the speed. The first race was a whooping, but the second race was much closer when I changed the position. This 4x4 pressure treated wood, there's a lot of irregularities in the wood. And depending on where the screw goes in really affects the performance. So I try to change it and make sure that one goes where and then the other one there and then this, that, and the other. Anyway, the next test we're going to perform is, of course, the Turk test. And this is where this bad boy shines. It is among the torquiest tools that I've ever tested. The only tool that had more torque is this one, believe it or not. The base model, Milwaukee. And I'm sure that this reflects highly on the design of my hoopty dyno. Some tools just seem to perform better. I don't understand why. And then the next test that we're going to perform is the power analyzer. So the dyno, performance dyno. And it's not staggering in performance. I didn't test this one because it's just such a dadgum hard. Well, I might test it. Let me go ahead and test. I want to go ahead and test this one, and we're going to get back. We're going to show it. One more show it. Just for doo-doos and giggles, I'm going to show you just how much of a pain in the gonads setting up this stupid thing is. The power analyzer. So basically, it becomes a bridge betwixt the battery and the drill. And you have to make all the connections. See all that crap going on in there, and then you have to connect everything on this end. It's really a two-man or a two-human being job. I want to be politically correct here. And then after you got it all set up, you can see how many watts and amps and volts per minute and amp hours. You know, everything growing boy would like to know about the drills. So let me see if I can't find a big old screw to screw in here. It's a real straight up pain in the ass trying to get going because all of these connections are so loose. Alright, so I'm going to come back once I get my act together here, and I have blasted the back out of more than one battery doing this, touching things and doing things that I wasn't supposed to do. Fresh with it, and then it showed me what time it was. A couple times I got showed what time it was. Man, this is a mother tape owner. Oh God. Together. Alright, let's see. Okay, I got that, this, and now this. There we go. Uh-oh, I'm into my table. I felt it lift. I think we got data. We got our data. The next test is handling and ergonomics. So let's watch the review the footage. And as you can see, this one's got a little more zip, a little more pep in its step. It bips the screws in there just a little bit faster. It's nothing like the Fuel FX or the Fuel XR or whatever. Or no, the Fuel, just the Fuel. There's nothing else after that. But the Fuel just has so many dadgum rip'ems to it. This one just can't screw fast enough. And it doesn't have as much stank behind it as the Fuel. It's just not as, anyway, let's proceed. But coming back to, like, you know, how the tool actually feels in the hand, and they're both extraordinary. This is probably the most comfortable tool I've ever used, and this one, it's on up there. You know, they have nice thick ass overmolds. It's a little bit softer. Actually, I think that might be why this one's thicker, because it's got more squish to it. Actually, this one might be as comfortable. It's just a, yeah, it's particularly comfortable, and it's got all these gears down here, which are ridiculous. I've never used anything except high gear, wide ass open all the way, 100% of the time, all the time. I don't even know why you'd use the other things. It's got a nice thick overmold though, TPE, so thermoplastic elastomer. That's butylene. That's the stuff that if you get petroleum on it, it starts to stink them like the dickens. It smells like human varmint. This has got the same TPE, thermoplastic elastomer. So both butylene overmolds. This overmold's got more pushing for the cushion for the pushing. You know, you talk about the switcheroonies, and this one, they both, you can tell this one's a different switch. The throw is a little bit easier and smoother to delivery than this one. This is the best feeling switch I've ever felt in my days of switch pushing. Right, okay, anyway, so moving on. The next test that we're going to perform is the rip'ems test. So 34. And as you can see, this one taps out about 3,500, and that's not, you know, that's not mind-bendingly fast. There are tools that spin faster. It's on the higher end, but it's certainly not the fastest that I've ever seen in my life. All right, so we're in it, but before I pop the top, I want to acknowledge how transformery they both look. This one has a very obvious transformer thing going on, and I don't mind it, but I know some of the old fogies are not too fond of the transformer deal. So, cracking it open for the first time, and geez, the build quality is extraordinary, but wow, look how similar it is. The motor almost looks identical. The drive assembly, or the hammerhead assembly, is, you know, this one's got a little bit more mass to it, but the design is very similar. So let's start at the bottom, and then you can see these blades are identical. This one's got some dielectric grease on it. This one's got some more safety protocols built in with all these, and wiring this thing up to the power analyzer was absolute hell. I had to get a little, well, each one of these had to be connected through my panel eye and then to the battery. It was not a fun thing to deal with. So moving up to the board, to the ESC, electronic speed control, you can see both of them are potted. Very similar design. This one's got a big old giant heat sink on the bottom though, this cast heat sink. But the actual physical design is quite similar, and you can see, I think they both have a, so they both have a 50 volt, no, this one's a 35 volt 2200 microfarad capacitor, and this is a 50 volt microfarad capacitors. Got a little more length to it. But they're both potted with epoxy. You can see how it's smooth. This elastic potting is kind of wavy and bumpy. And of course this one's got the gear selector and the mode selector, which interfaces with these tactile buttons. I like that. Nice. And then they got all these Molex style connectors. Everything could be disconnected. So if you got yourself in a predicament, you could replace this board and you wouldn't have to scrap the rest of it. That's really, really cool. Look at this little T90 little bus. These are little baby buses they use in automobiles. And it's actually got a bigger bus in the little scrawny drill. I don't understand why they would do that. The gauges, it's it's damn near identical in design. You can see the the leads for the three different phases of the brushless motor. They're sticking out of about the same exact location. The colors, you can see that the phases are run differently, so obviously it's a different design. You got blue on the outside, blue on the other side of there, white in the middle, not nooch, but just the center phase. And then you got the orange phase on the outer side. Let's move on up to the switch, the potentiometer. Like I was saying, this is one of the hot ding-a-lingest switches I've ever pressed. It's got an excellent little bellow on it to prevent dust ingress. They both do, but this is a quality Japanese Omron. See that? That's primo, baby. And then the little switchy switch feels really good. And then you've got the leads. So these are the ESC leads, and I can show you what those look like. Let me get something. So it's basically the same as this, right? So this is a brushless ESC, and then this is the potentiometer for it to control the flow of electrons through it. But it's very similar with what the juice doesn't flow through the switch. This regulates the juice that flows through the leads. It looks like it's been squishied from the factory. That's not great, is it? Definitely not. But it's beautifully well routed, and then they used heat shrink tubing over the leads. You don't see that on American tools. The tools are actually made in Japan. But the thing that's so fascinating to me is the motors almost look identical, right? Yes, they do. Let's take a gander at the over molds and then the actual molds. Yeah, look at all the meat. That's got a fat handle. Look at all the meat on the over mold. You can see how thick it is versus this one. And there's a lot more complicated geometry. This is just man, that's a fantastic looking part, son. It's PA6 GF30 as expected. They both are. That's glass fiber reinforced nylon. This is a much more complicated part. By an order of magnitude more development time went into this, and it's like a science. They have differentially cool these things to keep them from twisting. Look at that. You can see that there's a lock nut in there for the little handle, the belt clip, and then you got this. These are probably silicone bumpers for the battery. Yep. Anyway, so let's yank it about, get them apart, look at the business end. Oh, one thing that I want to really, that surprised me with the cheap one had the auto chuck, and then the more expensive one they didn't. I don't know why they would have just used the one from the other one, but obviously they're different chucks. The design is different. It just looks different. It's different. The fan on the back of this one is bigger, I guess. to move more air. I don't know why the fan, oh, I see. Yeah, it's actually transverse, so the air goes through it this way, whereas this one, the air starts on this side. They both have bearings. It's like identical bearings, but these are sealed bearings, 5 millimeter internal diameter, high speed bearings. Let's see if we can't get it out. Yeah, there we go. So let's pop. Dang, son. Yeah, that's nice. And you see there's 3 planetaries hiding down in there. Normally you only see 2 planetaries on these. Yeah, see that one? See, there's only 2 little planetaries in there. Let's see if I can't shine some light on the situation. See, there's one, and then there's the other one. You can't see it, trust me. So they went the extra little bit to put another planetary in there, I guess, to deal with extra Turk. And then we got the actual motor, and it's a, they usually are 6. This is 25-degree offset, and this is a 33. So these are obviously different motors. It's apparent. This one's been skeeted on. Yeah, look at that. So grease is squirting out the back of it. I don't know if that's supposed to happen, but it wouldn't. You wouldn't think so. Probably doesn't matter. But this one is, there ain't no squirt going on there. This is the Hall Effect sensor board. So, but the actual size is like, I think they're identical. Yeah. Yes. See the stacked laminates that make up the armature, or the stator, and the armatures are inside of it. But it looks like the exact same size motor as far as, I think it is the exact same. And we're gonna yeet out the rotor. Okay, well that's different. This one's got a smaller pinion. This one's got a big old meaty pinion, and then they got another sealed bearing on the end. But that's an oil-like bushing. What does that rub on? Oh, that's what seals this. No, it doesn't seal that. What does that oil-like bushing do? Oil-like bushings are oil-impregnated bronze, and they're used for friction mitigation. But you usually only see them where they touch a surface. I don't know. But the rotor is actually physically larger here, got more length. But this one's got, well, it's just physically larger all the way around. That's actually quite a surprise. You can see this one is a 4-pole, and I'm sure this one's a 4-pole too. So that's quite a surprise. Surprise-a-rooney. Well, I guess that's it. You know, I guess my final notes are these are almost identical drills, other than this was designed to handle a little more power. Other than that, I would say that this motor probably could be modified slightly, which I think that's what they did. Yeah. You can see that this one has smaller, more windings, and this one has larger, fewer windings. And the larger, fewer means most speed, and the smaller, more means more torque. You can see the Hall Effect sensors hiding down in there. Okay, that's it, friends. Until next time. Okay, score. So performance. It's got good performance, not extraordinary performance, and I'm going to give it an 8 in performance. Ergonomics, the tool feels fantastic. I mean, Japanese people, they really know how to design tools. I'm going to give it an 8 and ergonomics. Build quality, legendary Japanese build quality. Is the best built tool I've ever seen, hands down. I'm going to give it a 9.5 in build quality. The electronics are great. I mean, here again, Japanese people, they don't use crap in their tools. That's why they're expensive. I'm going to give it a 7.5 in electronics. Innovation, I love that they put the 40V big boy in this. So I'm going to give it an 8 in innovation. Value, horrendous, horrible value. It costs a lot to get into this ecosystem because all the components are expensive. I'm going to give it a 5 in value, and then you'll see the total score here. So that's it. You can leave your score at review.wfskills.com. Peace.